Here, we'll introduce you the lab environment. We begin by Cisco Nexus Dashboard Fabric Controller, or NDFC, is a centralized system used for managing data center fabrics that run NXOS. The goal of this hands-on is to give you practical step-by-step experience using NDFC to automate configuration, building layer 2 and layer 3 connectivity, and visualize the entire fabric from a single dashboard. This training uses a simulated environment containing Nexus 9000V switches, CSR 1000V routers, EXSI hosts, and Linux servers, giving you a full end-to-end miniature data center to manage. So this workflow is divided into logical stages: setting up the initial conditions, building, registering a fabric, configuring network services like VLANs, HSRP, and OSPF, deploying and validating the changes, and finally integrating virtualization with the vCenter. Each step demonstrates how NDFC abstracts away complex NXOS configuration, letting you push changes at a scale from a single controller instead of touching devices one by one. Your first task is learning how to enter management plane. Nexus Dashboard acts as platform hosting NDFC as a service. You authenticate to ND using admin credentials. Once inside, you launch Fabric Controller application. This separation mimics a real-world deployment where ND hosts multiple operational services like NDI Insight or Orchestrator, each serving different functions. Now, you are shown with the core topology: two leaf switches, two spines, two CSR routers acting as a northbound core, servers behind the access layer. You will also see EXSI and web host for testing connectivity. Each device's management interface, management 0, has been pre-assigned with IP, so NDFC can reach and manage them over an out-of-band management network. So this is important because NDFC communicates with switches strictly through management 0 for configuration and telemetry. This shows the end states you will build: VLAN 20 and VLAN 10 stretching across the fabric. HSRP gateway runs on the spine for both VLANs. VPC pair links between the spine and between leaves. Port channels connecting leaves to ESSI and the servers. Layer 3 OSPF adjacency between the spine and CSR routers. So this is a fully functional multi-tier data center design, just scaled down for training. You will watch NDFC automatically generate all purple NXOS configuration to achieve this architecture. The ND overview gives you visibility into three major areas: cluster health. This ensures the ND services are running properly. Developing services like NDFC and NDI nodes showing the ND applications in the cluster appliance in the cluster. From here, you will use the left side bar or top bar to navigate to all required NDFC functions. So this UI standardizes access regardless of whether you are managing ACI, NDFC, or multi-site developments. Now, you take a deep look at the top bar of ND Nexus dashboard. The top bar is essentially your global control strip. From here, you can quickly jump between an admin console and a developer's services like NDFC or NDI. You can also access your user profile, adjust settings, um, check for critical system alarms. This bar is always visible no matter where you are, acting as your quick navigation highway across the platform. Understanding it earlier helps you move smoothly while managing the fabric. And the left menu offers the structured layout of everything the dashboard Next dashboard manages. It includes an overview page where you can see cluster health and active services. Sites section where different fabrics like ACI and NXOS are listed. The services sections where modules such as Fabric Controller are located. You will also find the system level configuration, logs, analytics, and node information. This menu is what you will rely on most heavily for day-to-day NDFC operations. Next, you will learn to launch NDFC itself, and by selecting Fabric Controller from top navigation bar or go through Admin Console, Services, NDFC, you enter the central engine of the lab, and this is where you create the fabrics, onboard switches, um, develop configurations, and manage everything at a network-wide scale. This is the heart of hands-on training, right? Once NDFC loads, you will see its own dashboard. It displays the fabric health, switch status, pending alarms, disabled interfaces, and other operational metrics. This dashboard is meant to give you an instant sense of the fabric stability. From here, you can branch into fabric creation, topology visualization, switch onboarding, or policy department is the mission control room for everything you config. Here you get a breakdown of key operational sections inside NDFC. You will use dashboard for high-level views, topology for real-time network maps, LAN fabrics for creating and managing fabrics, switches to see all management devices, right? And interfaces to inspect and configure individual ports. Operations is for image management, reports, compliance, and event logs. So in this step, you will mainly work with LAN fabrics, switches, interface, and topology sections. You are reminded that NXOS lets you run commands from any configuration mode. Unlike older iOS systems, you can run show version, show run, show module, and many others even when inside configuration terminal. This makes troubleshooting faster because you don't need to back out to privilege mode. You also practicing using question and tap completion. This features that help navigate the NXOS efficiently, right? NXOS uses a module feature model where many protocols and capabilities are disabled by default to reduce overhead. You must explicitly enable features like interface VLAN, telnet, or NF overlay before using them. You also learn that interface names use a consistent format. Everything is under interface Ethernet. You can configure interface ranges easily. All this purpose to prepare you for understanding how NDFC automates the same features at scale. Now let's take a look at installation and basics. This will review the fundamental requirements before NDFC can manage the fabric. You need switches with working management zero interfaces, proper VIF management routing, supported NSOS platforms. Uh, this lab environment already had everything pre-configured, so your job is simply to understand the underlying expectations where NDFC takes care of the orchestration. Now, you revisit the initial switch setup just to confirm how everything is wired. The spines and the leaves have a host name set, management IP addresses assigned, and the default routes configured inside the management VIF. This configuration is required so NDFS can reach the devices over out of a band management. In real development, this part will be done manually or via POAP, PAPA. But in this lab, the foundation is already laid. All right. Let's walk through the first time logging behavior on actual Nexus switches. When logging in through the console, NSOS asks you whether you want to enforce secure password standards and whether to use this setup dialog. In this lab, everything is already configured. You skip automatically dialog and logging in using provided admin's passwords, right? Here you go. This reinforces the how NSOS boots with minimum configuration and why NDFC later becomes valuable for automating the full build out. Next is a how management interface and management VIF are configured manually. You set a hostname, enter the management VIF, assign an IP to management 0, configure default routes. This demonstrates the minimum foundation required for NDFC to take control of the switch without management 0 reachability. NDFC cannot push configuration or retrieve telemetry in production. This basic bootstrap is done for every switch before onboarding them into NDFC. Now, why management zero ports is special? Unlike data interfaces, management zero is tied directly to management VF and exists physically on the supervisor or chassis. This design allows out-of-band OOB management that is isolated from the data plane. NDFC relies on this dedicated path to make sure even if the fabric is misconfigured, management access remains unaffected. So this separation increases resiliency and prevents locking yourself out during development. Now we zoom out and understand the next dashboard as a whole. ND is a unified automation and operations platform that can run multiple services such as Fabric Controller, Insights, SAN Controller, a multi-site orchestrator. It can run in private cloud, public cloud, or hybrid setups. This just position ND not just as a management GUI, but as an entire ecosystem meant to replace siloed tools with unified operations. We use NDFC, but you get a sense of ND's larger capabilities. Then ND runs as a physical appliance, a virtual appliance on VMware or KVM or a multi-node cluster. Each option has their own resources requirements, such as CPU, RAM, and storage. This matters because NDFC performances scalability depends on choosing the correct ND development. In here, the ND instance is already deployed, but this will give you a realistic foundation for real-world deployment. 3.1 is a bit of old version, but I still talk about it. This is how ND evolved from separate components into a single target image. Previously, ND, NDFC, NDI, or NDO each require their own installations. With ND 3.1, again, this is a bit of old version, everything is bundled into one iOS or OVA. This makes the installation simpler and ensures the version compatibility, of course, of service. You don't deal with version mismatches anymore. A major operation, no improvements, the highlights just right here. You could take a look. Where ND uses a single image, each internal service still has their own version number as such as NDFC 12 or NDI 6. During the installation, you choose which services to enable. You need additional services later. you must reinstall ND because services cannot be added after initial setup. In here, NDFC is already enabled. You avoid this step, but important detail for architects planning their environment. Different ND network interfaces. The management interface is used for GUI access, authentication, okay, NDP DNS system operations, and the data fabric interface is used for communicating with switches for onboarding, provisioning, discovery, and telemetry. All right, ND requires both networks to be properly reachable with recommended Linux bonding for interface resiliency. Here, only OOB management network is used, simplifying the setup, all right? And what you see is the best practice for connecting ND. Management networks should be high availability bonding. Data networks should support low latency connectivities to switches. RTT guidelines here are listed for node to node and node to fabric communication. This ensures the cluster stability and a reliable switch onboarding. In here, environment is small, but design ensures you follow same principles used in enterprise development. The hardware sizing for different NDFC development scales. A single node virtual ND can manage up to 50 switches. A 5-node cluster can support up to 400,000 switches depending on fabric type. Physical nodes offer higher scale. It also shows how many physical interface systems are given NDFC instance can support. These numbers give a realistic sense of how NDFC can grow uh, with your data center and why clustering may be necessary. Let's understand NDFC license tiers. Um, Cisco groups data center networking features into Essential, Advantage, and Premier packages. Essential includes basic Layer 2, Layer 3 networking. Advantage adds multiple multi-site capabilities. Premier adds advanced day 2 operations tools for NDFC. Specifically, you need at least the essentials license for every switch you intend to manage. Even though this is a lab, understanding these tiers helps you understand how features scale in real development. Now we'll enter the initial setup stage of the hands-on. So this phase focuses on creating a fabric, onboarding switches, assigning roles, configuring VPC pairs, and preparing the environments before any VLANs or routing are introduced. NDFC uses building templates to align all these setups with Cisco best practices. So we'll make a transition from preparation to actual configuration task now. So go to LAN, fabrics. We're gonna create a fabric. Let's name it classic LAN fabric. Now, enhanced LAN, classic LAN contains validated Cisco best practice for NXOS fabric using transition layer 2 bridging with VPC layer 3 routing at an aggregation layer. By choosing it, you are leveraging automation for HSP configuration, VPC infrastructure, VLAN, SVI development, routing policy alignment. So the template dramatically reduces the risk of misconfiguration. Click select. After choosing the template, you have a configurable parameters. HRP type, HSRP, routing protocol, OSPF, OSPF process, tag and areas, VF and the global MTU, VLAN ranges, DNS, NTP, syslog service. These settings define the baseline behavior of the fabric. Most items use default loaded from the template, but here you explicitly set OSPF as routing protocol and add OSPF area and process tag values. NDFC will later push these settings automatically to all relevant devices. When we use BGP, that's for the 65001. And for the routing protocol, if you don't want a BGP, okay, we can pick OSPF. And we're going to enable performance monitoring. Then we wanted to go to protocols. Here we'll assign a tag 100 and OSPF area ID, say 000, and now click save. Double click LAN fabric, go to switch. We'll have to import out of my switches. And here's my seed switch IP. Let's uncheck preserve configuration, make it all green field. Let's just pick my switches. They are all manageable. Close that. And we want to assign the spine to the new role, but I will do that later. Say we first then want to create out a fabric. All right. So this fabric, we all wanted to go for external fabric, and we'll pick a new fabric that's for external connectivity network. This fabric will contain two CSR 1000V routers, and these routers simulate the upstream core of a data center. You assign go to this quiz and choose external connectivity network as a fabric type. So the template is designed for layer 3 only devices and external routing domains. So creating a separate fabric helps maintain a separation of design intent. All right. And here I configure external fabric parameters because the template focuses on L3 connectivity. I will specify a value such as BGP AS65001 and enable uh, disable monitor monitoring feature. Uncheck this and enable this. Click save, double check, switch, and we're going to assign. Don't forget, this will be iOS XE, the SR, and Let's add these two CSRs routers. Close it. Checklist 2, and we'll set a role to be a core router. Click OK. Now, it needs to understand the functional role of each CSR within external fabric. So I select CSR1 and CSR2 and assign their core router role. This ensures NDFC treats them as L3 devices responsible for external routing exchange. We're going to assigning this role determines how NDFC applies templates, right? The core routers receive the routing policies, where aggregation access devices receive bridging and the VPC policies. Assigning these roles is essential before deploying any routing configurations. And now go action and recalculate. In this case, you validate that there are 0 pending lines, and we will just close. Let's verify the status course the external fabric. So in sync is crucial. Any out of sync devices indicates the configuration drift and manual changes that must be corrected. All right. For next step, we'll close this fabric and go to LAN fabric. Go to switches. What we want, we want to pick spines, and we want to set a role to aggregation, right? Aggregation. Okay. Like aggregation. Click OK. Both spine 1 and spine 2, and we're gonna assign them aggregation. Leaf 1, leaf 2 are assigned access role. So these roles define which template segments apply to each device. Aggregation gets HSRP gateways, SVIs, and OSPF routing. Access gives host-facing policies, VLAN trunking, VPC downlinks. So this role-based approach is what makes NDFC automation accurate and predictable. Okay. Now we'll go to VPC pairing for spines and leaves. NDFC automatically builds VPC domain configuration, peer link, port channel, peer keep live link, system priority, peer switch settings. Then we're going to repeat the same pairing for leaf 1 and leaf 2. So just with a few clicks, NDFC deploy the full best practice VPC structure that normally require dozens of CLI commands per switch. High availability and redundancy are now in place. You look how we do that, and so first we'll go to spine. That click spine, and we want to say VPC pairing with spine 2. Save. Okay. And now leaf want to pair with leaf 2. Simple as that. Okay. Now we want to deploy, recalculate, and deploy. Lots of lines to be deployed. Side-by-side comparison, you can see everything at all the configuration to be added and deploy all. Close all that, and you see they are all in sync. Take it to topology, configuration, and double-click classic LAN. NDFC automatically maps all switches, links, and the VPC structures. This shows both configuration and operational status. You can drill down into any node and hover over the link to reveal interfaces and visually inspect the health of the fabric. So this topology engine is dynamic and updates as you deploy new networks and routing configurations. It becomes a valuable troubleshooting and a visualization tool. Let's go back to LAN fabrics and classic LAN fabrics. Go to switches and check spine 1 and an action here. Okay, take a look again. Action here, VPC overview. It takes time for VPC peering. All right, you drill deeper into VPC consistency. All right, this just shows you detailed configuration alignment between the VPC pairing. Let's check the VLAN allow list, spanning tree parameters. So you can check MTU, port channel settings, and the global VPC parameters. These just highlights any mismatches. In the tab, everything is full consistent, and this automated inspection prevents outage caused by human misconfigurations. Okay, go to consistency, VPC detail. There you go. Peer link details. Peer link status side by side. Okay. Send, receive, they both successful. Close this, go to close that, and action added fabric, bootstrap. Here you could enable bootstrap, enable DHCP, make sure DSP v4, start scope. Okay. So while doing the POAP, enable this zero-touch onboarding of new switches. When a switch boots without configuration, they contact the DHCP server and downloads a script and automatically applies base configuration. NDFC can act as a POAP server, enabling automated provisioning pipelines. So it's particularly useful for large-scale data centers. This lab just explain your pop, but does not require using it yet. Now close that. We'll go to next task. We want to add a VLAN 10. So that's great. Let's say my network 10, VLAN ID is 10, and this is my 10.10.10.254/24 interface. Standby 10.10.10.2. Pop up to advanced. So make sure that's defaults. Active member HSRP. Standby is 100. We want to make a group number. Let's say that's group number 10. And start create. Now we'll create another one. My network 20. VLAN ID is 20. So 20.20.20.254/24, 20.20.20.1, 20.20.20.2, and that's it. And pop the two advanced. Same thing. Want to make a group. That's 20. Great. Let's go to interface. You want to create interface. Make VPC. We want to use VPC leave 1, 2. And let's enable configure mirroring. So we can configure on both switches. Peer member interface U1 6 to the servers, and MTU, we don't want to jumble. Let's use default. And this automatically populates the peer 2 interface. They are defaults. Enable the port fast. MTU is default. Save that. Now close. Now go to interface groups. Create interface group. Say IG for EXSI. Ethernet default. The only one part in the shared trunk host. BBTU is true, of course, and MTU is not jumbled, just default. Let's create. Now let's create it and to create an interface group. Make IG for server 3. Make VPC. That's it. Create. Let's confirm both IG EXSI1, IGES as server 3 now exist. So these will be used next to attach VLAN networks to host ports. Interface groups form the bridge between logical networks and physical switch ports. What we do next, go to interface. All right, we will find interface. Let's say interface start with Ethernet 1/5. Okay, this is my one interface 1/5, and device name contains leaf. Okay, now pick 1, pick 2, and click more. and we'll assign interface group. Interface group IGEXSI. Now save. We're going to find another interface. Interface equals VPC2. We'll find this VPC, leave one, leave two, okay? And what we should do is we want to assign interface group. This interface group is to server 3. Save that. Okay. Now, we're searching interface group, and that contains interface group IG. Let's pop up to network. ESSI is with my VLAN 20, so we want to go to 20. This will be assigned to interface group. This group is the ESSI. Create this. Save. Now my VLAN 10 is going to assign to the IG server 3. Now both VLAN 10 and VLAN 20 now show attached interface groups. This mapping is essential because NDFC views SVI and VLAN propagation only after the logical network is attached to at least one IG. Now the fabric is ready for final development. Action, deploy. Deploy all. Close all that. Click the switch. Now the configuration in sync. Let's verify. Go to interface. Interface equals Ethernet 1/5. Now up and up network is confirmed 20, and I interface group IGSSI that's confirmed. Scroll a little bit, you could see rest of it. Now we want to make sure that VPC is all rare to my server 3. So let's go to interface. Pretty sure that's a VPC. There you go. My spine 1, spine 2 VPC, leaf 1, leaf 2 VPC, network 2 networks, all right, and both VLAN 10, 20. All right, that's the one within the network, and I wanted to confirm interface VPC2. The second VPC goes to the IG server 3. IG server 3 confirmed. Network 10. VLANs 10. And we can click this. It should show me everything, but uncheck. We want to say interface contains VLAN. VLAN 20, 10, 20 should all be up on my spines. Yep, they should be on up in my spine switch. And scroll down a little bit. And this is my IP and prefix. Go to switch. Click one spine and one more. And we want show command. Pick one show command. That's a show HSRP brief. All right, execute. Here it shows. Now let's go to server 1. Let's ping 20.20.20.254. Pings are okay. Server 2. Ping 20.20.20.254. The gateway. Okay. Server 3. Ping 10.10.10.254. Ping is okay. Okay. I verified again and all switches are in sync with SVI interfaces, trunks, and host facing ports are fully aligned with the design. So this completes layer 2 and layer 3 service provisioning stage. The fabric is now ready for OSPF routing configuration. Close this. Close. And we go to Cisco LAN fabric interfaces in spine. Okay, so let's pick interface equals Ethernet 1/5. This E1/5, 1/5 is connecting to CSR1, 1/6 is on spine 2 alone to CSR2. Okay, so we know spine 1 is /5, and let's edit policy to pick is interface, okay, routed host. We need IP 10.30.2, 24, MTU, normal MTU, and IP router OSPF 100 area. This is what we want, freeform configuration. Save it. And close. Pick spine 2, same port 1/5. Edit. Pick interface router host policy. Okay, no VF, just IP 10.10.40.2, 24, normal FTU, same thing, IP router, OSPF 100, area, save that, close. We have pending configuration. That's okay. And we know on the interface 1/6. Let's pick interface equals to Ethernet 1/6. Pick 1/6. Edit. Same policy. Routed host. 10.10.60.2/24. Use MTU IP router OSPF 100 area. Save that and close. We're missing something. If you know, we have to create loopback interface. So we're creating loopback. We're creating loopback for spine 1. Okay. Spine 1 IP. Okay. Loopback 0. Save that. 1.1.1. Close. And we want to create an interface. Loopback interface. Device on spine 2. Loopback 0. IP is 2.2.2. Save it. Close. Go to switch. Okay. Only pick spine 1, spine 2. Action. Deploy. Deploy all. The deploy complete. Go to interface. Now we can find out what are these routed ports in here. Interface. No. Should be policies that contains routed. Should see 3 interfaces on spine 1 and 2. There you go. Go to spine 1 CLI. Okay, show IPOSPN neighbor. Neighbors up. Admin. The IP OSPF neighbor. Neighbor 2 neighbors up. We show IP route OSPF-100. Show IP route OSPF-100. There you go. We can see the route, right? Same thing here. Show IP route OSPF-100. They are learned routes. If I go to web host 1, I will ping 2020. Ping. Sorry, I should go to web host ping 2020. Routing is here. 20.2050 is my server 2 in EXSI. Same thing works. 10 between server 3. That works too. Now, begin integrating the vCenter into NDFC. VMM integration helps visualize virtual machines and their connectivity. So this enables the correlation between physical and the virtual network state. This enhances the troubleshooting and the monitor. Let's do it. What we do is go to virtual management, virtual infrastructure manager, action, add instance. All right. vCenter, we could do Kubernetes OpenStack and the IP of vCenter. And default administrator, username is there, password, added, success. Now, if I go to topology, I see a vCenter. Go inside here. I have one compute and I have two virtual machines. So one or two. Okay. Go back. Classic fabric. Now. Okay. So how do I want to show you. Okay, this is right. Just compute. Now, okay, it shows my server 1 and server 2. So once the integration completes, NDFC topology view shows the vCenter host is VMs, virtual switches. You can drill down to see how each VM is connected. Okay. This closes the loop between the physical and the virtual network. Let's go to the LAN, fabrics, classic. Now you will find virtual infrastructure, virtual machines are there. So one, or two. Now, at the end of this, we'll give some tips. First is how NDFC provide preview policy templates, covering the interface types, VPC settings, and routed interfaces, and more. So this template implements Cisco's best practices and ensures the consistency across the large fabrics. They reduce the operator error and simplifies the master configuration tasks. They are great. You can add policies, delete old ones, and adjust the settings. They are customizable, and these makes NDFC extremely flexible for customizing fabric behaviors. And this NDFC allows you to create custom policies, including CLI-based freeform templates. Okay, these custom templates let you push arbitrary NXOS configuration to selected switches. Very useful for unique development. The freeform templates feature let us to push custom CLI commands to one or multiple switches. NDFC merges these commands into its automation pipeline, while just maintaining the compliance, offering this both automation and granular control. Okay, NDFC continuously will monitor device configuration for drifts. If someone manually changes a switch, system detects the deviation and marks the device out of sync. You can preview differences and redeploy intended configuration to restore compliance. This protects against the human error and the configuration inconsistency. You take a look at image management. You upload image, create image policies, attach them to the switch, stage the image, will validate impact, and perform ISSU in-service software upgrade when it supports. This just centralizes the fleet upgrades across large environments. NDFC also simplifies switches replacement using POAP. When a switch is marked for replacement, NDFC stores its configuration. Then the new switch boots, will use POAP to fetch its configuration, and NDFC restores it automatically, and this eliminates the manual reconfiguration during hardware failure. All right. It also supports configuration only and full backups. It stores locally or on remote servers. Full backup includes reports, logs, and metrics. Backup policy can run on schedules. Resource can be granular per switch or fabric-wide. So this ensures operational resilience, right? NDFC can take a backup and store large multi-site configuration fabrics. It's include member fabric intents in external or classic LAN fabrics. Individual switch restore is also supported. This is critical for disaster recovery planning. And finally, you could explore the performance of dashboards, which visualize, you can see CPU, memory, interface usage, and traffic trends. So these metrics helps troubleshooting issues and optimize performance. The reports can be exported and emailed automatically. So this completes the operational toolkits inside NDFC. All right, that's the whole thing. NDFC basic uh, hands-on lab. Hope you enjoy. Please leave your questions below. Have a wonderful day.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.